Hi, Doc Rivers here. In this video, I'm going to talk about selectivity and enantiomers in Diels-Alder reactions. I'm going to show you my model for how to draw these consistently. A Diels-Alder reaction is a 4+2 cycloaddition reaction. It gives 6-member ring enantiomers of Endo and Exo Stereochemistry based primarily on the electronic influence of the dienophile functionality. Here we show you what we mean. If you're unfamiliar with how to draw Diels-Alder reaction, see my other videos on that subject. So here we have the Endo and Exo Stereochemistry shown, where we have the 4+2 cycloaddition of the diene on the left with the dienophile on the right, where Endo would be dash wedged and on the underside of the ring shown in our structure. And Exo would be dash solid shown on the top face of the ring as we draw them. The selectivity of Endo and Exo is influenced by the functionality on the dienophile. Endo groups are shown on the left. They are called electron deactivating groups. On the right we have Exo, where we have electron activating groups. So let's draw some examples. In the case shown here, if we have a simple diene with an exo dienophile, we'll get the structure shown here with the wedge solid on the top face of the ring. If we treat it as an endo reaction, we would get the dash wedge on the underside of the ring. Once we've drawn the exo or endo product, to get its enantiomer, simply draw a dashed line to represent the mirror. Once you've done that, simply reverse the drawing, and there you have it, the exo enantiomer and the endo enantiomer. We show you here the mechanism, which is a paracyclic concerted reaction of 6-electron movement to give you exo or endo. In this example, we have a diene which has 6 strands configuration and an exo dienophile. It's exo because the functionality is alkyl. Therefore, when we carry out the reaction, we have the exo major product and we get the endo minor product. To draw its enantiomers, we simply draw a mirror as a dashed line and reflect it across the dashed line, and we have its enantiomer. It should also be noted that when the diene and dienophile are unsymmetrical, there are 4 other isomers that can be drawn. In this reaction, we show you an endo-favored Diels-Alder reaction because of the carbonyl aldehydic functionality, which is an endo director over the exo product. We draw the products, we draw a mirror, and reflect across that mirror, and we have the enantiomers. So essentially, when we carry out Diels-Alder reactions, we must always consider the possibility of enantiomers. And again, if the diene and dienophile are unsymmetrical, then we will get other isomers as well. Here's an example where we have a cyclic diene with an endo-directing dienophile. In this case, we get a bicyclo-addition reaction in which we get the dash wedge down underside functionality in the bicyclo ring, which is endo, which is highly favored. To determine its enantiomer, we simply draw a dashed line as our mirror, reflect across that mirror, and we have its enantiomer. In the case of bicyclos, particularly with endo directors, we rarely get the exo product. So there you have it, a systematic way of drawing enantiomers for Diels-Alder reactions.